Now that we have talked about the general ideas involved in continuous random variables, let's talk about some specific distributions, right, of continuous random variables. Okay, specific distributions. The first distribution that we'll talk about is the uniform distribution. Okay, the first continuous distribution, the uniform distribution, and first let's take care of the definitions, right? If X is a uniform random variable, this is how we write it. X is uniformly distributed between A and B, okay? So let me tell you that again. This is how we use the notation, right? X is uniformly distributed between A and B, the values A and B. And the density function is given as 1 over B minus A, X lying between A and B inclusive, and it's 0 elsewhere, okay? This is also important, yeah? It's 0 elsewhere. So you can tell that this thing here is a constant. 1 over B minus A is a constant. So when you have y equals to c from coordinate geometry days, you know that we are dealing with a horizontal line, yeah? Okay, we're dealing with a horizontal line. So that's what you'll see in a minute. So let me erase that. Okay. Okay, good. Now, so we know this and we know this notation and the PDF. The expected value of X, you can do it yourself, right? It's A plus B over 2. And then the variance of X is just B minus A squared over 12. Okay, we can derive this. I told you how to get it. Use this formula, XFX going from A to B. And then you can also work the variance of X by first working out the expected value of X squared, which will be X squared fx, X going from A to B. Now, if you do that, you will get this answer, B minus A squared over 12. That's your variance of X. And you can also do the CDF on your own. Okay, that's not difficult to do. We'll go from A to X. Okay, I'll have 1 over B minus A, and then I have dt, right? So when you do that, you'll get 1 over B minus A, and then I'll have a t, and then I have an x, and I have an a. So I'll have x minus a over B minus A. There you go. Okay, that's your CDF. Okay, now that we have talked about those important things, let's go ahead and do a simple example. You're told that X is uniformly distributed between 10,000 and 100,000. Okay, X is uniformly distributed between 10,000 and 100,000. Let's work in terms of thousands. Okay, so which means if I draw my PDF, so I'll have 10 and I'll have 100. Yeah, so I repeat, I'm working in terms of thousands. Yeah, so I have 10 and I have 100. So my height here should be 1 over B minus A. 1 over B minus A should be 1 over 90. Yep, that's what I've drawn here for you. Okay, I've written here K. I hope that you know K means what? 1,000, right? That's for kilo. So you know this value, that's the height. And these are the values on the horizontal axis. Good. Now, what do they want? They want the probability X lies between 15 and 50, 1, 5, and 5, 0. I repeat, we're working in terms of thousands. So the probability that X lies between 15 and 50 is this one here. Okay? The area below the graph. So the area below the graph, what is this value here? 35. What's this value here? 1 over 90. So it'll be 35 times 1 over 90. That's what you see here, 35 over 1 over 90. If you divide by 5, you will get 7 over 18, and we are done. Okay. Now they've asked you to work a conditional probability. Probability X lies between 15 and 50. given that X is bigger than 12. So we have got the idea behind conditional probability we have spoken about for quite a few times. So remember, it's just A and B. So excuse me, A given B will be what? The intersection, okay? A and B over what? Probability of B. So the denominator here will be probability X bigger than 12, right? So X bigger than 12. So if you mark in here 12, they want this thing here bigger than 12. Okay, so bigger than 12. Let me move the screen up a bit, yeah. Okay. Good. So bigger than 12 means 12 up to 100. So 100 minus 12 is how much? 88. So I'll have 88 here, okay? 12 and 100. And what's the height again? 1 over 90. So 1 over 90 times 88. That's what you'll see in the denominator. There you go. Okay, 1 over 90 times 88. This one here is intersections. So bigger than 15, less than 50. Okay, X between 15 and 50, given X is bigger than 12, is just the same as this one here, which we worked out as 7 over 18. And that's intersections, right? You can draw a picture here. We have got what? We have got 12, we have got 100, right? So I've got 15 and 50, right? 15, 50, and 12. So bigger than 12 is here, okay? Between 15 and 50 is here. So you know the intersection is just here. That's why it's 7 over 18. Use a calculator if you like and get your final answer, 35 over 88. Next example. We are given that X is a uniform random variable between what? 1 and A. And you're told that A is bigger than 1, yeah? Well, it should make sense, right? Okay, A should be bigger than 1. Okay. And you're told the expected value of X is 6 times the variance of X. Find A. So this is basically using the formulas, cleaning up the equation and cleaning up an equation and solving a quadratic, and you'll get your answers, yeah? So the expected value of X, that's easy. A plus 1 over 2. There you go. Variance of X, you know it very well, right? Is B minus A whole thing squared over 12. What is B here? It's A. So it's A minus 1 whole thing squared over 12. Where is it? Here. There you go. Just use the formula, yeah? And plug that in here. Clean this up, yeah? Clean this up. This is simple quadratic. And you will solve for A to get A equals to 3. Good. Next example. This question is taken from Abe Weishaus manual. So you have the manual, you can look it up, but I have the question here. You can look up Professor Weishaus' solution as well. Okay, but this is my solution, but our answers are all the same, right? Our method of approaching the final answer might be slightly different, but the final answer will be the same. Maybe I should move it up a little bit more. You're told that X is uniformly distributed between 0 and 10, right? Okay. X is uniformly distributed between 0 and 10. And what else? The X represents losses, yeah? Okay, represents losses. There is a deductible of how much? 2. Okay, a deductible of 2. Those of us who are in actuarial science, we talk quite a bit about deductibles. Yeah, a deductible means, you know, if you have a claim and it's below $2, you pay. If it's more than 2, then the insurance company will pay the difference. Okay, if it's below 2, you pay the amount. And if it's more than 2, the insurance company will step in and pay the difference. That's it, right? So now we have a deductible of 2. Find the CDF of the benefit paid if, very careful, right? Find the CDF of the benefit paid, yeah? If the policy holder, PH is what? Policy holder. experiences one loss. Yeah, this guy experiences one loss. I repeat, this solution is mine, so you can look up the manual for a different approach. Not to worry. Yeah, our final answer here will be the same. Okay. The CDF of the benefit paid, right? So I'm calling Y the benefit. Okay, I'm calling Y the benefit. So the benefit will be what? Good. Remember, I told you it'll be the difference, right? Anything more than 2, it'll be the difference. So Y will be X minus 2. Okay. So we can do a little bit of transformation. We have learned how to do this before. Okay. So I will let you do that. Probability Y less than or equal to Y will be probability X less than or equals to 2 plus Y. Okay. So let me tell you again, right? This is what I want to do. I want to find, but I know Y is X minus 2. So I just play around with the inequality and I'll have probability X less than or equals to 2 plus Y. And I know X is uniform between 0 and 10. And I told you earlier about this X minus A over B minus A, remember? Just use that. So I have 2 plus Y minus 0 over 10 minus 0. And you will get this answer. Okay. So that is the probability X less than or equals to 2 plus Y. So you can write your CDF. Yeah, you can write your CDF of Y very quickly. Okay, you can you can write the CDF of Y very quickly. We have got Y less than 0. That's easy. Okay, it's 0, Y less than 0. Y between 0 and 8. Why is this so? Remember, your X is between 0 and 10, right? Okay, so X minus 2 must be between, okay, and 0. Okay, so that's the reason why we have Y between 0 and 8. So we have worked this out, 2 plus Y over 10. And of course, anything bigger than 8, it'll be 1 to make sure that your CDF is complete.